Hey guys, welcome to Brad and Prad, to our second video of the try playlist. Now let's jump into a Leetcode question. So as you can see here, this is Leetcode question number 208, which is asking us to implement the try. So if you haven't watched our previous video, I'll attach the link in the description. Please do that. Please watch my previous video on the explanation of try. You'll have a better understanding for doing this question. So now here they're basically asking us to build a prefix tree, or also known as a trie. And basically, it's a design question where they're asking us to design the class and implement the functions insert, search, and starts with. Now, if you've seen my previous video, I've already covered how the trie data structure looks like, how we can insert words, how we can search for words, and how we can implement the starts with function. So now we have to write the code for that. If you see the example input, the first one basically initializes the try, and then the next one is the insert operation, where he's inserting the word apple into it. Once he inserts apple into it, then he's searching for the same word apple. He's searching for the same word apple, and then he's searching for the next word, which is app, and it should also return false since he hasn't inserted apple. He hasn't inserted app, and he's only inserted apple. Now, the next one is basically starts with app. This should return true because we have apple in our try and it starts with app. So let's dive into implementing the try class. So before we even go in writing the try class, we should actually write the try node class first. So just like for a tree or a binary tree, a graph, where we write the node class first and then the actual class later. Similarly, we'll write the node class first. Now, if you guys remember in my previous video, I've shown you how each node actually looks like over here. Now, this is the root node. The root node is having an array of pointers or an array of object ID references since we're doing Java. Now, and each node has this array of 26 array of pointers or array of object ID references, and also a Boolean flag. So this is how our node class will look like. And the try class will handle the insert, search, and starts with function. So let's jump back into that. Now, so for that, I need to first write a node class. So let's write it inside our try class as a static class. Okay. Static class node. Let's just call it node for now, for simplicity's sake. Now, why did I declare it as a static class? So it is for, again, simplicity. So I can directly use the node class over here. So if I want to use a node class, I can directly use it here. Now, if I don't mention the static over here, then what would I have to do is I would first have to mention the outer class first and then mention the inner class. So this is kind of tedious work. So hence I declare it as a static class. Now, in this static class, as I said, we have an array of pointers or an array of object IDs, which is what basically it is an object ID reference. Object ID of what? It is an object ID that represents node itself. So basically, the array, each and every element is referring to another node. I'll repeat that so you can understand it better. Let's go back to our previous example in the other video. Now, if you see here, each element of the array stores the object ID reference to the next node. What am I saying? Next node. So it's basically the class itself. So we'll declare an array. We'll declare an array of node itself. And let's just call it the chars array. Okay. Equals new node of 26. Then along with that, I also said that there is a Boolean flag, which represents whether it is the end of the word or not. So let's write that in as well. Boolean is end. So you don't need to explicitly write false here, since this is an instance variable. It will by default be false. Now, we'll also write a, so we don't need to write an explicit constructor, because by default, when the default constructor, which is already there, it will basically create an array of 26 pointers which all have null, and this will by default be false. So I don't need to write the constructor explicitly. Let's write a function. Let's write a function that will help me when inserting, searching, and doing the starts with function. So I'll call it boolean contains. So now if you remember, I also explained how we go to each and every node, we process the word character by character, and we check whether or not our node actually has the pointer or the object reference to the next character. So this is what that function will do. It will check whether that character exists or not. So what will I return? I will check whether in my character array. So again, this is a character. Now I need the index of the character. So what did I tell you in the last video? You take the character, you subtract it with 97, you get the index, the corresponding index of where the character or object reference to the next character node is. So I'll do ch minus, I don't need to do minus 97, I can directly do minus a. So this will be typecasted to 97. And I will check whether or not it's null. So I'm checking whether it actually contains, does it contain any node at this point? So I'm checking. So hence I'll return whether it's null or not. If it's not null, it will return true. If it is equal to null, then it will return false. So yeah, now we are done with the node class. Now let's go on writing the trie class. So now this is a trie class. Now inside the trie class, we'll have the root node. This is an instance variable, root node. That's all we need. Pretty much it. Now, when we instantiate the trie, we want to create a new node. We want to create a new node. So now I didn't write, as I said, I didn't write any constructor in the node class because it's not really required, because I want everything to be null and I want this to be false by default, which will already be handled by the default one that's there because I didn't write anything. Now, once that's done, let's now hop into insert. Now, what happens at insert? Let's go back to this. So I'm first at the root. Now, once I'm at the root, once I have A, I want to insert A. That means I'll create a new node for A. Listen to me carefully. I'll create a new node for A, and then I'll make sure at this index, it will point to this node. It will point to this node. So since we already have node chars equals new node 26, it is already storing object ID references, because in Java, if you guys know the primitive data types like, int, string, and even if I use the wrapper classes, now if I say int array, then each element is actually of type int. So I can access each number or each string, or each character or each boolean. So these are all the primitive data types. Now, what if the user creates a custom data type or a custom class, where here in our case is node. So what are we actually storing in that array? The node array that we created before, what is actually getting stored here? Now, in case of primitives, if it's an int, then a number is stored. If it's a string, the whole string is stored. If it's a char, the whole character is the character is stored. And if it's a boolean, either true or false is stored. Now, in a case of any custom user defined data types, the object ID reference is stored. And that's what I want, right? Now, with this understanding, let's go back and write this. Now, since I have to start from the root, I'll declare a temporary node variable and initialize it to my root. Now, once this is done, we want to traverse the whole word over here. So for each character, for each character in word dot to char array, we want to change this to a character array so we can access each character easily. Now, first I'll check. Right now we're at the root. Right now, temp is equal to root. So now we're at the root. So if temp doesn't contain, notice I used the negation operator over here. I've used the negation operator, right? Okay. Now, if temp doesn't contain the character, and where is this contains function? We've already written it here, right? Basically, if you want, you can write this directly, but for readability and ease of coding, we've written a function like this. So this will return me true or false, checking whether any object ID reference exists or a pointer to that node exists. Now, if it doesn't exist, then please in temp.chars at that index. So how do we get the index? We do character minus a. This will be typecasted to 97, like I said before. So if it's a, it will be a minus a, which is 0. So at 0 for character a, I want you to create a new node and point to there. So it'll create a new node for a and store it and store the object ID reference in chars at that index. So this is understood. Then once that's done, I want to traverse to the next node. So now I have to update my temp. What do I update my temp to? To this node that I have created now. How do I do that? So temp dot chars of ch minus a. As simple as that. So if the character already exists in the trie, then it just skips this line because it already contains. So this will return a false and then go to this line. It will then go to this line. So for readability, I'll write it like this. Yeah. So if this returns false, so the root already contains a, for example, then we just want to traverse. Otherwise, we insert and then traverse to that node. Is understood? Now, once we are done traversing the whole array, now if you remember in our previous video, I showed you an example for Apple. So let's go back to that example once. Now, here, once I have processed the whole word apple, I then change my boolean to true. So that's what I want to do here. So then temp dot is end. Is end basically means that it's flag for whether it's the end of the word or not. I'll then set it to true. So this is how I can insert words into my trie. Now for search. The search is basically almost the same as insert, but what do? We check whether our character exists or not. Okay, we check whether our character exists or not. Now I'm going to copy this and show you how it works. Okay, now since we are not inserting, we can remove this line. Okay, obviously we need to traverse, so this line is important. Now, if my temp doesn't contain, what was I doing over here? I was inserting. In this case, when I'm searching, if the character doesn't exist, what am I supposed to do? I'm supposed to directly return false because the character is not there in the trie. So notice how it's almost similar to insert. Okay, then once I've traversed the whole character. Now in the case of app, when I'm searching app is not there. So when I reach P, I know that it is not the end of the word. So what do I check? I check whether at node P, whether its is end flag is true or false. So I can simply return temp dot is end. So what happens in this case is, now when we're searching for apple, you can see it goes apple, it goes down, and then finally reaches E. Now we process the whole word. Now I'll check whether the flag is true or not. The flag is true, so hence the word exists. So return true. Now, in a case of APP, when I'm searching for APP, I'll first go to A. A exists. Since A is there in the root, I'll go to A. And then since P is there in the root node A, I'll go to node P. Again in node P, I'll search for P. And an object ID reference to node P is there. I'll come here. Now, I've traversed the whole word app. Now I'll check whether my flag is true or false. Since my flag is false, I'll return false. So hence, in this case, I'm directly returning whatever the flag is there. The is end flag at that node is there. Now, this case happens when I enter a completely different character. So suppose I enter, now here I only have A and C. Now if I say search for bus, now at B, there is nothing there. This is null. This is null. So since this is null, this will then, our condition over here will then, this will return true because again, I use a negation operator here. So since it doesn't contain anything, I'll directly return false because B doesn't exist. You never even inserted B. So this is how easy our insert and search functions are. Now let's go to starts with. Now again in starts with, it is similar to search. But the only thing I won't check is whether I have reached the end of the word or not. So if you remember in this example, what was I doing? I was checking whether once app was traversed, I'm checking at this node whether the flag is false or not. Right now, in starts with, I don't need to check that. So I don't need to, I'm not bothered about this flag. So I'll directly return true. So if I've traversed the trie like this, so from root I go to A, from A I go to P, like that, and I've reached P again, since it exists, and I've traversed the whole word, will directly return true now. True now. So it'll be the same as search. Now let's go back and implement our prefix function. Oh, sorry, starts with function. Oh, by the way, I have made a mistake here. This is of type array. So make sure you write that. Yeah. Now, since I said it's almost similar to search, so let's just copy this, paste it here. And now I said that we are not bothered about the, as I said before, we're not bothered about the is end flag. So we remove that. And if I've traversed the whole word or whole prefix to be more precise, then I'll directly return true because everything exists. Now in a case, let's just say I enter BUS. I'm searching for the prefix BUS and I only inserted apple. At the root level only, there exists no character B. So then this condition will apply and directly return false. Yeah. So now let's just change this to prefix and run the code. So yeah, that has been accepted. Now submit. And there we go. That's how we can efficiently implement trie. And now in the next videos to come, we'll go into more deeper applications of trie, how it's used in auto suggestions and all that, and the related Leetcode problems. We'll also see how trie can be used to store numbers, not just strings, and the related problems for that as well. Thank you.